Hello. Let's look at the solution for the problems that were given to you. The first one had 4 cases, A, B, C, and D. We'll look at each one of them. The first case, side A is 7 inches. Angle B is 40 degrees. And angle C is 30 degrees. Of course, the diagram doesn't look proportionate, but it's just generic. Now we notice we do not have 2 sides and the angle between them, which is the condition to use cosine law. Okay? And we do not have 1 side and the angle opposite to it, which is the condition for sine law. But since we have 2 angles, we should be able to compute the third one, which will help us use sine law. So that will be the strategy. Let's start the solution. We know that angle A is going to be equal to 180 minus angle B plus angle C, which gives us angle A to be 110 degrees. Now we're going to apply sine law, plug in the numbers. Use cross multiplication. Now side B is computed to be 4.79 inches. And we already computed angle A, so what's missing? We have one more thing to do, which is side C. So we're going to take this term and this term, cross multiplication, and we can solve for C. C should be 3.72 inches. Don't worry much about rounding now. If you have minor differences because of the rounding, that's not a big deal at this time. We're going to look at the rule for rounding later. Second case. A is 3 meters. B is 6 meters. And angle C is 48 degrees. So here we have 2 sides and the angle between them. Easy. That's cosine law. We are solving for C. Plug in the number. Let's see what this is about. Yes, please be very careful with this because we have this term, negative 2ab times cosine C. Cosine C could be a negative value depending on which quadrant the angle is in, which means negative times negative will become positive, and that could create some issues with the computations, especially if you're doing this directly on the calculator. So I suggest please use parentheses all the time, whether you're using a calculator or not. Let's continue. So before we were interrupted, we were plugging in the numbers to compute C. Now as we compute C, we can apply sine law to get the missing parameters. It should be easy and straightforward. Again, if you have minor errors because of rounding, don't worry about it, as long as it's close enough. Okay, next case. We have A, 8 feet, B, 7 feet, and angle A, 60 degrees. So here we have two sides, but not the angle between them, but we have the angle opposite to one of them, which means we can apply sine law. We'll plug in the numbers. If you have any difficulty remembering the arc sine, how to compute the angle using the arc sine, please let me know. If you're having difficulty with your calculator, let me know. But these should be the correct answers. Okay, next case. This one's a little bit interesting. We have side A 4 meters, side B 7 meters, and side C 9 meters. So we have 3 sides, but we don't have any angles. Which law can we apply? We can't use sine law because we need an angle opposite to one of the sides. We cannot use cosine law because we don't have the angle between two sides. However, we can still use cosine law, but in this case we'll be solving for the angle instead of solving for one of the sides. We'll see how to do it. Plug in the numbers. Cosine C is the unknown now. So we'll clean up the others, and we'll have that cosine C is equal to negative 0.286. Then we'll compute angle C using the arc cosine function. It's a negative value, which means it's going to be in the second quadrant. Now that we computed angle C and we know the side opposite to it, so we should be able to apply sine law to get the other parameters, which would be the two missing angles. Alright, next problem is a little bit different. We have a boom supported by a pin on one side and then a cable on the other. And we're asked to compute the length of the cable and the angle the cable makes with the horizontal. So first we need to compute length AB and to determine the angle AB makes with the horizontal. And that's where some of you got confused what that means. So let me make this a little bit larger in the middle here. So again, we're supposed to find the angle that AB makes with the horizontal. I'm going to draw a horizontal line. So the angle that we need to compute would be this angle here. All right, not the angle inside the triangle, but this one here. Okay, so first let's draw the triangle ABC. Straightforward. Two sides and the angle between them, 8 and 5 and the angle 40. Apply cosine law, and that should compute AB for us. So in this case, C, so side C is side AB. If you notice here, I put a bar or a line above AB. That is just a convention to say that this is length AB, not the algebraic multiplication of variable A times variable B. So AB should be 5.26 feet. Right. Next, we need to compute the angle, which is this angle here. Let's give it a name. I'm going to name it alpha. We're going to need a larger diagram, so let's center this one and make it a little bit bigger. Now we computed side AB, 5.26 feet. So we have all sides and we have one angle opposite to one of them, so we can use sine law, right? Which will give us this angle here, the red one. Let's name it theta. Now we get the value of this angle. We should be able to compute alpha, because let's do some work here. If I extend this line, the horizontal line, and the vertical line, they will intersect at a point. Let's name it D, for example. Then here we have this right triangle, which means the angle at B is going to be opposite the angle at C. So this one is 40, the other one will have to be 50, which means angle alpha will be equal to 50 minus theta. And theta is computed in the previous step. I know we didn't do it here, but I know that you can do it yourself. I'm just discussing the procedure. So at the end, angle alpha should be about 12.4 degrees. If you come up with 12.3 or 12.5, that's acceptable. Okay, that's one method. There is another method that I want to show you. Again, we're going to work with this triangle CDB. In this triangle, side DB over side CB is going to be sine angle 40, because DB is the opposite to angle C. Which means we can compute side DB because we have CB using cross multiplication. Now I'm going to take that little triangle. Now we know the adjacent to angle alpha and the hypotenuse. So using the cosine function, we should be able to compute angle alpha. I recommend that you rewind the video a little bit and watch this again and work the numbers, because I skipped some steps on purpose to give you the chance to do it yourself. Okay, well, I hope this helps you, and then please let me know if you have any questions. Thank you.